clarification sessions. Then you can use my promo code as displayed on the screen here to get an additional 20% off. Okay, so our next session will be on vitamin D. Let's begin. So today we're taking vitamin A. Let's begin with a clinical case. So a 15-year-old boy came to the hospital OPD with complaint of difficulty in night vision. Okay, he appeared to be malnourished and came from poor socio-economic background. On examination, conjunctiva was found to be thick, dry, and wrinkled. Grayish white triangular plaques adherent to conjunctiva were also found. There was hyperkeratinization of skin. Okay, too many symptoms given. The person is deficient in which of the following vitamins? So your options are A, D, E, and K. So once we've done with all the vitamins, it will be a piece of cake for you to do such clinical cases. Okay, so let's begin with the introduction of vitamins. So what basically vitamins are? They are organic compounds which are present in very small, minute quantities in various food substances, and they are needed for the growth and maintenance of the body. And your vitamins are dietary essential. Okay, so you have to take your vitamins through diet because your body does not synthesize vitamins. So these are those organic compounds which are not synthesized by our body, but you have to supplement them through diet. Certain exceptions are there. There are certain exceptions. That is, there are certain vitamins that are synthesized by your body. So they are endogenously synthesized by the body. Now, what are those? So you can divide them into two types. That is, those which are synthesized by the body. That is, your own body is synthesizing it. So they include niacin, your vitamin D, and the other category is in the body. Now, what is in the body? That is, your body is not synthesizing it, but it is being synthesized by somebody else in your body. So what is that somebody else? That is your bacterial flora in the intestine. So there are bacteria in our intestine. They are synthesizing what? Vitamin K, biotin, and pantothenic acid. So these are those vitamins which are synthesized in our body, but not by our body. And what are the vitamins that are synthesized by our body? They are niacin and vitamin D. If you remember in tryptophan metabolism, we had studied that niacin was one of the products that was formed from tryptophan. And also, this is the only vitamin that is derived from an amino acid. Okay. Now, your vitamin D, it is synthesized from 7-dehydrocholesterol by exposure to UVB rays in 290 to 315 nanometer in the skin. So when we'll be talking about vitamin D, that is in our next class, we'll see the synthesis of vitamin D in detail. So these were the examples of endogenously synthesized vitamins in our body. So if in a question, if you get an MCQ where it is not mentioned that about the endogenously synthesized vitamins, that in or by is not mentioned. So, and the question only says which of the following is the endogenously synthesized vitamin, and you have in the options both niacin and vitamin K. So your preference will be given to those vitamins that are synthesized by the body, okay, rather than in comparison to the vitamins that are synthesized in the body, okay. Okay, let's take an MCQ, a vitamin derived from amino acid. So I just told you that is your niacin. So niacin is the only vitamin that is derived from an amino acid. And which is that amino acid? That is your tryptophan. Okay. Now moving on to the classification of vitamins. So your vitamins are classified into fat soluble and water soluble. So your fat soluble includes vitamin A, D, E, and K. And your water soluble vitamins are, that is your B complex vitamin and your vitamin C. So today we'll be talking about fat soluble vitamins, and in that specifically vitamin A. So a little comparison between fat soluble and water soluble vitamins. So absorption of fat soluble vitamins is through chylomicrons, obviously because they are fat soluble, and also you are taking them through diet, so they become what, they become exogenous. And if you remember, when we studied about chylomicron metabolism, I told you that your exogenous tags, they are carried in chylomicron. So similarly, your vitamin, that is your fat soluble vitamins, they are also carried and absorbed via your chylomicron. Okay. Now storage. The fat soluble vitamins are stored in liver and adipose tissue. And excretion, they are not excreted. Obviously, they are being stored, they are not excreted. And toxicity, yes, if in excess, they can be toxic and they have varied functions. And your vitamin K is the only fat soluble vitamin which has a coenzyme role. Okay. So your vitamin K has a coenzyme role, whereas your water soluble vitamins, they mostly have the function as they function as coenzymes. Okay. Now the absorption of your water soluble vitamins, they do not need chylomicrons for it. It can be directly absorbed from the intestine. So they are directly absorbed from intestine. And storage, your water soluble vitamins are not stored. So when obviously they're not stored, they are excreted, and they are excreted in urine. Toxicity as such, no toxicity because they are being excreted, except for vitamin B6 and niacin. They show some toxicity. Okay. I hope it's clear. Now moving on to vitamin A. So we'll be talking about vitamin A now in detail. And let me tell you one thing, that your vitamins, they are very important, and not just for your UG but also for your PG. In 2023, there were like some around 13 MCQs from biochemistry, and you can say like 9 to 10 were from vitamins. So your entire biochemistry on one side and vitamins on one side. So you can imagine the amount of weightage given to vitamins. Okay. Now let's begin with vitamin A. So your vitamin A, it includes retinoids and carotenoids. So these are the two categories in which you divide them. So what are retinoids? Your retinoids are the active form of vitamin A, and you get them from animal sources. Now compounds which are chemically related to retinol, they fall under retinoids. So in the strictest sense, you can say vitamin A is your retinol, okay? Although retinoids have different forms, that is your retinol, which is the functional group is alcohol. Your retinol, where the functional group is aldehyde, and retinoic acid, where the functional group is COOH, carboxylic acid. So your retinoids, they are the active form of vitamin A, and you get them from plant sources. And in the strictest sense, if you talk, so your retinol is vitamin A, but there are other forms as well, that is your aldehydic form, and your carboxylic acid form, that is retinoic acid. Now the other category of vitamin A is your carotenoids. Now your carotenoids are provitamin. Now what is provitamin? That they have to be converted into active vitamin A. So your provitamins, it can be converted to active vitamin A. Okay. Now, your carotenoids, they are derived from plant sources. And most prevalent carotenoid is your beta carotene. And the richest source of beta carotene is your carrot. Okay. And there are around 600 different carotenoids. For example, you have beta carotene, you have lutein, zeaxanthin, and lycopene. So beta carotene is an antioxidant. In fact, all your carotenoids are antioxidants, but especially beta carotene. Then your lutein and zeaxanthin, they are used both in the treatment of macular degeneration. So both of them are used in the treatment of macular degeneration. Okay. And your lycopene, it is used in the treatment of prostate cancer. So these are one-liners important from the point of view of MCQs. You can get MCQs based on these, that which of the following carotenoid or which derivative of which of the vitamin is used in the treatment of macular degeneration or prostate cancer. Okay. So now moving on to the structure of vitamin A. So I'm just telling you, you only simply, if you just remember that it is composed of iodine rings and isoprenoid chain, it is more than enough. Although for clarity purpose, I have shown these images so that only you understand, but you simply don't need to know these structures. It is very much okay if you don't know these structures. What you need to know is, sometimes you might get asked in MCQ that how many rings are present, or the structure of vitamin has the following. So only these two lines are more than enough. So vitamin A usually have a single beta ion ring. So the catch point is they have single beta ion ring plus an isoprenoid chain. But your beta carotene, it has two beta ion rings. So this is the only difference, that your beta carotene has two rings, whereas rest of all your vitamin A structures have single rings. Okay, so you can appreciate that from this image. This is your beta ion ring and this is your isoprenoid chain. Okay, now what is the difference in beta carotene? You can see it has one and this second. So it has two beta ion ring, and whereas rest of all your vitamin A, they have single ion ring. Okay, and what is an isoprenoid unit? It has 5 carbon unit. So you can appreciate it by, it looks something like this. So this structure here, this is your isoprene. Okay. So you have this isoprenoid chain in the structure. Okay. But you need not know these structures, know where you will be asked to draw them or something like that. Okay. Now they can be changed into their respective forms. Your retinol, it has alcohol as functional group. Your retinol or retinaldehyde, it has CHO, that is aldehyde, as functional group. And your retinoic acid, which has carboxylic acid as its functional group. Okay. So here, the difference will lie here. So this is what you can see, it is retinol, that is retinaldehyde. If you replace it with COH, it becomes retinoic acid. Similarly, if you replace it with alcohol OH, it becomes retinol. Okay. Now moving on to the metabolism of vitamin A. Now metabolism of vitamin A, I'll be discussing it under 3 heads. That is its absorption, transport and storage. That is how your vitamin A is absorbed, then how is it transported, and then how is it stored. So if through the diet, you get your vitamin A. Now, basically, your plant source will give you what? It will give you beta carotene, and your animal source will give you what? It will give you retinal ester. So your vitamin A from plant source, you're getting it in the form of retinal esters, and from animal source, and your from plant source like carrot, mangoes, papayas, you are getting it in the form of beta carotene. Before I explain you this diagram, it is just to simplify for you, I'll give you a hand drawn diagram. Okay, so it'll be better for you to understand. Okay, now let's assume that this is your intestinal lumen and this is your intestinal cell. Okay, now what happens is Your vitamin A, you're taking it through diet. Now, if it is plant source, what do you get? You get beta carotene. And if it is animal source, the vitamin A is in the form of retinol ester. Okay. Now your plant sources basically just like I discussed, they have carotenoids, and the most important carotenoid is your beta carotene. So you get your beta carotene. Now this beta carotene is absorbed from the intestinal lumen into the intestinal cell. Now it reaches here into the intestinal cell, and here it is acted upon by an enzyme that is known as dioxygenase. Okay. Now your beta carotene is acted upon by beta carotene dioxygenase or dioxygenase enzyme simply, and what it forms? It forms retinol. So what is dioxygenase doing? It is cleaving your beta carotene. So on cleavage, what do you get? You get a single iron ring and an isoprenoid unit. See, you can appreciate this with the help of the diagram. So this is the only purpose why I had inserted diagram, so that you're able to understand. This is your beta carotene. Okay. Now your beta carotene, when it is acted upon by dioxygenase, what happens? It cleaves to beta carotene here, and you end up with retinol. Okay. So this is what is happening in your intestinal cells. Yeah. Now from your animal source, you have retinol ester. Now from this retinol ester, what will happen? Your fatty acid is removed, and what do you get? You get retinol. So your retinol ester, it is hydrolyzed, and what has happened? Your fatty acid is removed. Now you get this retinol, and this retinol that enters from the lumen into the intestinal cell. So your retinol has reached here. Now in the intestinal cell, to this retinol coming from the animal source, fatty acid is added, and also to this retinol which was coming from your plant source, fatty acid is added, and they form what? They form again retinol ester. Now this retinol ester, it is carried in your chylomicrons. To where it is carried? To your liver. And what is liver? Your storage organ for vitamin A. Okay. Now let's read what it says. So retinol esters from animal source, like I told you, and beta carotene from plant sources. They're absorbed from intestinal lumen into the intestinal cell. All right. Then they are transported via chylomicrons and reach liver. Okay. Then so your all fat soluble vitamins are carried to storage organs via chylomicrons. Like I explained to you earlier, because they are fat soluble, and they they are fat soluble, and all your exogenous tags, like they were being carried from the intestine via chylomicrons. Similarly, they are fat soluble and not water soluble vitamins, so they are also carried inside your chylomicrons. Now the retinal esters are stored inside liver in the perisinusoidal cells or etio cells. Okay, so this is where they are stored in the liver. The name of the cells is important. You need to remember that. Then when the body requires vitamin A, it is transported in the blood to target organs with the help of two transport proteins, forming a ternary complex or trimolecular complex. Now, what it is trying to say, that you've had your diet. I'll repeat that. You've had your diet, and in your diet, there was, if you've had something like mangoes, papayas, or carrot, then you will get beta carotene. And if you've had something like your plant sources, then from egg and all, you will get your retinal ester. Now, these forms of vitamin A, they from the lumen, they are absorbed into the cell. Now, into the cell, what happens? How is beta carotene absorbed? It is directly absorbed from the lumen into the cell, and there your beta carotene is acted upon by an enzyme, that is dioxygenase, which splits it into two and forms what? Your retinol. And your retinol ester, it is hydrolyzed in the lumen and your fatty acid is removed and it forms retinol. Also, an important point to note here is that the most abundant fatty acid that combines with your retinol is palmitic acid. So either you can call it retinol ester or retinol palmitate. Okay. Anyway, so this retinol, which was your retinol ester, which was hydrolyzed and fatty acid removed in the lumen, it is then this retinol is absorbed from the lumen into the intestine. There again in the intestinal cell, your retinol, it combines with fatty acid to form what you can see here. It again combines with fatty acid in the intestinal lumen to form retinol ester. And now this retinol ester, it is carried inside chylomicrons. Okay. Now what happens? This chylomicron, it reaches your liver. Now your chylomicrons, if you remember, your chylomicrons, they were having the ligand ApoE, and the receptor for this ApoE was present. The receptor was present on liver, if you remember, right? Now what happens? It reaches the liver and there it is internalized and stored in the liver, where in the perisinusoidal cells of the liver. Your vitamin A is stored in the form of retinal esters. Now, when the body is requiring vitamin A, so your target organs, like example in the eye, in the skin, where there is function of vitamin A. So when those organs they require vitamin A, what will happen? So vitamin A, which is stored in the liver, it will be transported via blood to those target organs. Okay. Now, but the catch point is that it is not soluble in blood. So how will it be transported? Therefore, it will be transported with the help of two transport proteins, because it is not water soluble and it is a fat soluble vitamin. Okay. Now, what are those transport proteins? They are your retinol binding protein and transthyretin. So, transthyretin, if I break this, trans is for transporter, thy because it is also transporter for your thyroid hormone. And rectin because it is transporting retinol. So from the liver, it is transported via blood to the target organs with the help of these two transporters. Okay. That is your retinol binding protein and your transthyretin, forming a ternary complex. That is tri-molecular complex. So this will be your retinol and this will be your retinol binding protein and this will be your transthyretin. So this forms a ternary complex or tri-molecular complex. Okay. Now let's take an MCQ. Beta carotene, precursor of vitamin A, is oxidatively cleaved by. Now your options being dioxygenase, oxygenase, hydroxylase and transferase. So we just studied that in the intestinal cell, it is cleaved by dioxygenase. Okay. Now moving on to the functions of vitamin A. Now vision, it is involved in vision. Form of vitamin A that is involved is 11 cis retinol. Then skin and mucosa for maintenance of epithelium. So it is also your vitamin A is also needed in skin and mucosa for maintenance of epithelium. Then for reproduction, which form is needed? Your retinol form is needed for reproduction. Then regulation of gene expression. It is brought about by retinoic acid. Then it is also involved in growth and development, in tissue differentiation, and it acts as an antioxidant, most important antioxidant being beta carotene. Then your beta carotene also has photoprotective properties. Therefore, it is also used in cutaneous photosensitivity. Okay, so it is also applied in treatment for cutaneous sensitivity. Okay, let's take the function vision, that how is your vitamin A involved in vision. So 11 cis retinaldehyde, it combines with opsin protein to form what is known as rhodopsin. Okay, and this is your world's visual cycle. We will see how this is working. So for dim light, you must have studied. For dim lights, we need rods, and for colored vision or bright vision, we need cone. Okay, so your rods, they contain a pigment or a protein which is known as rhodopsin. So your rhodopsin are needed for dim light vision. Now let us see how vitamin A is involved in the formation of rhodopsin and how we are actually able to see things. Okay, and this entire cycle, this is known as world's visual cycle. So your all trans retinol, it changes into 11 cis retinol. Let's see, and all this is happening in the retina. Okay, this is happening in the retina. In the retina, what is happening? Your all trans, I hope it's clear. So all trans retinol, it changes into what? It changes into 11 cis retinol. And then this 11 cis retinol changes into 11 cis retinaldehyde or 11 cis retinal. Now this 11 cis retinal, like it's mentioned here, this 11 cis retinaldehyde, this combines with opsin protein. Okay, you can see this. So this 11 cis retinaldehyde, it combines with the lysine residue in the opsin to form what? To form rhodopsin, and this rhodopsin is also known as visual purple. Okay, now what happens when light falls on this rhodopsin? You can see light written here. So when light falls on this rhodopsin, a series of photoisomerization reactions take place. Okay, so this is your rhodopsin being formed. Okay, now what I'm saying is when light falls on this rhodopsin, what happened? A series of photoisomerization reaction take place. Okay, now, during those photoisomerization reactions, different isomeric forms are formed, like you can see photorhodopsin, bacthrorhodopsin, lumirhodopsin, metarhodopsin 2, and metarhodopsin 3. And these photoisomerization reactions, they are taking very less time, okay, less than a second. It happens in fraction of seconds, okay. You can see 10 raised to the power minus 15 written. So, fraction of seconds is needed for this. So now during these photoisomerization reactions, an isomeric form known as metarhodopsin 2 is formed. And this is important. This isomer is important. Okay, now this metarhodopsin 2, why is it important? Because it is able to initiate a signal cascade pathway. So it ignites a signal cascade pathway. Therefore, this metarhodopsin 2 is important. How? We'll discuss in the next session. Okay. Now, this metarhodopsin, it releases opsin. You can see it liberates opsin. Opsin is released and it forms what? All trans retinaldehyde. This all trans retinaldehyde will again form what? It will form, you can see here, all trans retinol. So this is happening in the form of a cycle, and which is known as Wall's visual cycle. Okay, so I'll just recapitulate this briefly so that you are able to understand, and also you are to some extent you are able to memorize it and make it more clear. So what is happening in the retina is that your all trans retinol, it changes into 11 cis retinol, which then changes into 11 cis retinaldehyde. Now this 11 cis retinaldehyde, basically if you don't remember all the reactions, but overview is that your 11 cis retinaldehyde, it combines with a protein that is known as opsin. When combining with it forms rhodopsin, and that rhodopsin is also known as visual purple. Now when rhodopsin light falls on this pigment, that is your rhodopsin, what happens is a series of photoisomerization reactions will take place. A number of isomeric forms are formed. Now, the most important being your meta-rhodopsin 2, because this meta-rhodopsin 2 is able to initiate a signal cascade pathway, which ultimately leads to the generation of a nerve impulse, and you're able to see things. Okay. Now, this meta-rhodopsin then will degenerate, and your opsin will be released from it, and it will again form all-trans retinaldehyde, which then changes into all-trans retinol. So this is happening in a cyclic form, and which is known as Wald's visual cycle. Now let's have a look at the action of your meta-rhodopsin 2. That is the signal cascade pathway that it is igniting. What happens is your meta-rhodopsin 2, it activates a G protein coupled receptor known as transducin. Okay, so this transducin, it is inactive, and in its inactive form, it is bound to GDP. But your meta-rhodopsin, it is going to activate this G protein coupled receptor transducin, and in its active form, it is GTP bound. Okay. Now this transducin, it activates an enzyme which is known as phosphodiesterase. Now what do phosphodiesterases do? These active phosphodiesterases, they change cyclic GMP into 5' GMP. And this 5' GMP is responsible for closing of sodium channels. So the sodium channels which were open, they close because of this 5' GMP. And where are you getting this 5' GMP? It is basically because of the actions of meta-rhodopsin 2. Now, when the sodium channel closes, it causes hyperpolarization. And this hyperpolarization, it leads to the generation of nerve impulse. Okay, usually action potential happens because of depolarization. Now, this is an exception where your action potential is taking place not because of depolarization but because of hyperpolarization. And this hyperpolarization then it generates nerve impulse, and you're able to see things around. So, this is why your meta-rhodopsin 2 becomes important. And this is how your vitamin A is involved in vision. So now you know how vitamin A is involved in vision, and why do doctors tell you to have carrot and it's good for your eyes. Must have been listening this since the very beginning of times. Okay, so this is the biochemistry behind it. Okay, now moving on to the next important function of vitamins, that is, they're involved in regulation of gene expression. So it helps in growth and development, and also in tissue differentiation. The most important form is your retinoic acid. Retinoic acid, it binds to nuclear receptors. What else bind to nuclear receptors for its action? That is your steroid hormones. Okay. So your retinoic acid, it binds to nuclear receptors and activates them. Now these active nuclear receptors, they then binds to response element of gene and bring about regulation of gene expression. So retinoic acid acts via nuclear receptors just like steroid hormones. When we will study signal transduction and action of various hormones, there also you will come across this, that how your steroid hormones are working via nuclear receptors. So what it says is that your retinoic acid, it binds to what? It binds to nuclear receptor. And your nuclear receptor is activated. Now, this active nuclear receptor is going to bind to response element. This is the response element. So it binds to response element and regulate gene expression. Therefore, ultimately leading to regulation of gene expression. Okay. Now it says that there are two types of receptors, that is RAR and RXR. Now, what is the difference between these two receptors? Let's have a look. So RAR is retinoic acid receptor, the full form for it. Okay. The form of retinoic acid that acts as ligand for RAR is all trans retinoic acid. So all trans retinoic acid, they are going to act via RAR receptor. So active RAR binds to receptor element, binds to response element and regulate gene expression. Okay, now what is RXR? So the form of retinoic acid that acts as ligand is 9-cis retinoic acid. So your 9-cis retinoic acid is going to act via RXR receptor, and all your other rest, all trans retinoic acid, they're going to act via RAR receptor. But the catch point here is that your all trans retinoic acid, it was acting as a ligand and it would bind to the receptor, and this active nuclear receptor, it would bind to the response element on the gene and then regulate gene expression. But there is a slight difference in the mechanism of action of RXR. What happens is, your 9-cis retinoic acid, it's going to not directly bind to the response element. Rather, it would first dimerize with the active receptor of either vitamin D or thyroid hormone. See, RXR, it says dimerize with active vitamin D receptor or thyroid hormone receptor. Now, this heterodimer, it is going to bind to the gene and regulate gene expression. Therefore, in case of vitamin D deficiency or in case of thyroid hormone deficiency, you can see what will be manifested: vitamin A deficiency. So impairment of vitamin A functions will be seen. I'll explain you this more easily with the help of a diagram. Let's suppose this is what your all trans retinoic acid. So your all trans retinoic acid. It acts via which receptor? RAR. And for learning purposes, I'll give you a little mnemonic trick. So RAR has A into all trans retinoic acid. So you can remember RAR and A. So A here, A here. So all trans retinoic acid acting via RAR receptor. Okay. So this acts as the ligand, binds to the receptor, and what happens? Then this goes and binds to the response element. Simple. But in case of 9-cis retinoic acid, let's suppose this is your 9-cis retinoic acid. It binds to the RXR receptor. Now, this will not directly bind to the response element. What happens? First, it will form a heterodimer. So, this RXR binds to vitamin D receptor, active vitamin D receptor or thyroid hormone. Okay. So, this here, and it binds to vitamin D receptor. Let's suppose this is your vitamin D and this is your vitamin D receptor. Now this heterodimer, now you can see this is the heterodimer. So this heterodimer consists of active RXR receptor and active vitamin D receptor. Now this heterodimer is going to bind to the response element. Okay, here. So these are the two kinds of receptors for your vitamin A. So therefore, your vitamin A deficiency will be manifested also because of your thyroid hormone or vitamin D deficiency, because your vitamin active RXR will not be able to bind to the response element until and unless it forms a heterodimer with the active vitamin D or thyroid hormone receptor. Now moving on to the deficiency of vitamin A. Now loss of vision to green light. The loss of vision to green light, it is the earliest sign of vitamin A deficiency. Okay, this is the earliest sign. Now note, I say sign and not symptom. Okay, earliest sign and not symptom. Now what is the difference? Because the patient will not be able to recognize this. Okay, and why is there loss of vision to green light? Because your rhodopsin is very sensitive to 500 nanometer. Rhodopsin very sensitive to 500 nanometer, and this 500 nanometer is where your green light falls. Okay, now nyctalopia, that is your night blindness. Now this nyctalopia, night blindness, this is the earliest symptom. Okay, so your earliest sign will be loss of vision to green light, and your earliest symptom will be nyctalopia, that is night blindness. The person is not able to see in dim light, not able to see in dim light. Okay. Next being dryness in conjunctiva and cornea, which is known as xerophthalmia. Then keratitis, that is inflammation of the cornea. So there will be photophobia because of keratitis. Photophobia. No, Bitot spot. What is that? That is raised area in conjunctiva. Now, corneal ulcers, that is known as keratomalacia. Most common vitamin deficiency is your vitamin A deficiency, and the most common, it is also vitamin A deficiency is the most common cause of preventable blindness, and this is important. You can get asked is this in MCQs. Now, let's take a MCQ before moving forward. So deficiency of vitamin A causes xerophthalmia, hypoprothrombinemia, megaloblastic anemia, pernicious anemia. So your answer will be xerophthalmia. Okay. Which was dryness in conjunctiva and cornea. Now moving on to the manifestations of the skin. That is, it causes follicular hyperkeratosis. It is also known as papular dermatosis. It is also known as toad skin. Okay, so the your maintenance of epithelium, it needs vitamin A. In case of vitamin A deficiency, there is blockage of adnexal gland leading to toad skin. Now, toxicity of vitamin A. Usually, toxicity is very rare, but it is seen as Arctic explorers, because in Arctic explorers, their main food being what? Polar bear. So they consume polar bear liver. So the liver is the storage organ for vitamin A. So indirectly they're consuming what? Excess of vitamin A, leading to toxicity of vitamin A. And the organelle that is damaged in hypervitaminosis is your lysozyme. So toxicity is rare, but it is seen as Arctic explorers, and some of the manifestations of toxicity of vitamin A can be headache, nausea, vomiting, hip fractures. Okay, now why is hip fracture seen as a manifestation of vitamin A? Because your vitamin A, it increases osteoclast activity. So your vitamin A, it increases what? Osteoclast activity. So because of which there is increased resorption of bones. Therefore, what happens? You're more susceptible to fractures, especially hip fractures. So that was about toxicity of vitamin A. Now, vitamin A intoxication cause injury too. The options being lysozyme, mitochondria, endoplasmic reticulum, and microtubules. This is an asked question from AIMS 2020, 2006. So your answer being lysosomes. Okay. Moving on to the therapeutic applications of vitamin A, beta carotene, as we've already discussed, it is an antioxidant. It also has photoprotective function, therefore, it is used for cutaneous photosensitivity. Your all trans retinoic acid, it is used for mild acne. It is used to prevent skin aging. Now, this retinoic acid is also known as your tretinoin. And this is a very, you must have like on Instagram and all dermatologists and every skin influencer and blogger talking about tretinoin, isotretinoin these days. But they're all prescription grade topical creams, so you cannot just use them like that. So your tretinoin, it is used for treatment of mild acne, and it is not a teragogenic. It is also used for preventing skin aging. And then you have 11 cis retinoic acid. It is your teratogenic. Therefore, it is not, you must have heard influencers telling you this is not pregnancy and lactation safe. Okay. And it is also known as isotretinoin. This is used in the treatment of cystic acne and childhood neuroblastoma. Now, moving on to the source and RDA of vitamin A, that is the required daily allowance and how much of it you can have it. So, sources we've already discussed. Once again, let's have a look. Your retinoids, you were getting them from plant sources like liver, egg, butter, cheese, milk, fish, meat, and your carotenoids, they were derived from your plant sources. Your carrot being the richest source for beta carotene. Mangoes, papayas. Okay. Now in children, you need 400 microgram per day of vitamin A. And in pregnancy, you need 800 microgram. So the requirement just double in pregnancy as to what the children need. In lactation, you need 950 micrograms per day. In men and women, they need 600 micrograms per day of vitamin A. So with this, we come to the end of the class. Thank you for watching. If you have any queries, you can ask. We've done with vitamin A, very important. All the vitamins are very important. Vitamin B complex, as we move forward, you will see it has a lot of clinical applications associated with it. Vitamin A is also very important. So all of your vitamins are very important, especially not only for your UGs, but also from the point of view for your masters if the pattern doesn't change. As of now, it's the hot topic current favorite for the questioners. We've studied about the metabolism, the deficiency, toxicity, the RDA, the receptors, Wall's visual cycle. If you have any queries, we've taken up MCQs. Then the storage organ, where was it stored, which cells were involved. These are the points where your MCQs get asked from. These one-liners, okay, that I keep telling repeatedly. The first sign, the first symptoms, and then all those, the important manifestations when you see in the eye, beta spots, nyctalopia, keratomalacia, okay, and then the general discussion, okay, like which one on what stored, which are excreted. Okay, so with this, we come to the end of the class. If you have any queries, I'm right here, you can ask. In the next class, we'll be taking vitamin D.